A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students of 12th class subject Botany, Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, you know we have studied the Mendels' third law of inheritance, and you know the first law was the law of dominance, and the second law was the law of segregation, which we have completed in our previous lectures. And yesterday we have studied the third law, that is the law of independent assortment. And the law of independent assortment, first of all we have defined it, what is this law of independent assortment, and then we have explained it, but this question remained incomplete in our previous lecture. Now today we will move ahead and we will study this law of independent assortment, the second half portion of this law of independent assortment will be discussed today in our lecture. So our today's topic is Mendels' law of independent assortment, which is now continued, and we will see how the ratios are formed, and we have also come to know that this Mendels' third law of independent assortment can be explained on the basis of Mendels' dihybrid cross. And the dihybrid cross, you know, has given the ratio 9:3:3:1. On the basis of that dihybrid cross, we will try to explain you this law of independent assortment. Now, first of all, we will start here that Mendel observed four types of phenotypes with two parental and two new combinations. This we have seen in our previous lecture, that Mendel observed four types of phenotypes in which two were the parental combinations and the two were the new combinations. Mendel assumed that genes for characters are present in pairs in the parents, and tallness and red color of flower are dominant. This we have seen in our previous lecture, that the red color of the flower and the tallness were dominant. Tallness and red color of the flower was dominant. Both tall red, which is denoted by capital T and small r, parents, and dwarf white represented by small t, small r, parents were homozygous. These were homozygous. So both tall red parents and dwarf white parents were homozygous. This we have seen, that the tall red represented or denoted by capital T, small r, and the dwarf white represented by this small t, small r. These both tall red and dwarf white parents were homozygous. The F1 from these plants would be heterozygous. In the F1 generation, we will find the plants of the heterozygous nature, that is, the F1 from these plants would be heterozygous, tall red, heterozygous tall red, denoted by capital T, capital R, small r. This is the condition of heterozygous tall red. Now the allelic pair, capital T, small t, will segregate. So you should remember here that the allelic pair capital T small t will segregate to produce two types of gametes, that is capital T and small t, in equal ratios. So the allelic pair capital T small t will segregate to produce two types of gametes, that is capital T and small t, in equal ratio. Similarly, capital R small r pair will segregate to produce two types of gametes like capital R and small r in equal ratios. You should this understand here this, that the allelic pair capital T small t will segregate to produce two types of gametes like capital T and small t in equal ratios. Similarly, capital R small r pair will segregate to produce two types of gametes like capital R and small r in equal ratios. Now, in F2 generation, Mendel showed that both the pairs of genes would behave independently of each other. In F2 generation, Mendel predicted that both the pairs of genes would behave independently of each other. Out of 16 possible combinations, 9 plants are tall with red flowers. So you should here note this, that in F2 generation, Mendel predicted that both pairs of genes would behave independently of each other. Out of 16 possible combinations, 9 plants are tall with red flowers, 3 plants are tall with white flowers, 3 plants are dwarf with red flowers, and 1 plant was dwarf with white flowers. This is the typical dihybrid cross ratio, 9:3:3:1. So when you will add these 9 plus 3 plus 3, it comes 16. So these are the 16 possible combinations in which the distribution is 9 plants are tall with red flowers, 3 are tall with white flowers, 3 are dwarf with red flowers, and 1 was dwarf with white flowers. So genes for size. Genes for size and color. Genes for size and color assorted themselves, producing new combinations. Genes for size and color assorted themselves, producing new combinations. So when we will represent here that the parent is, we will take the tall red flowered, denoted by capital T, small, capital R. When we will this cross this in dwarf white, represented by small t, small r. So gametes will be capital T, capital R, and small t, small r. In F1 generation, tall red flowers will be formed, this denoted by capital T, capital R, small r. तो ये आपने उधर जो हमने ये सब्जेक्ट मैटर प्रोड्यूस किया ऊपर, इसमें आपने देखा है. तो दिस इज रिप्रेजेंटेड बाय हियर इन diagrammatically in this. Now we will make the table. You can see the table, these 16 combinations, how these 16 combinations are formed. Gametes from F1, male will be here, and arrow shows the male, this in horizontal position, while as in vertical position you will see the female. So when we make the column in tabulated form, here you will see the female, male, and these are the ratios: capital T, capital R, capital T, small t, capital R, and small t, small r. When we will cross these four, you will see here, when this will be multiply, यहाँ पर आप देख सकते हैं. तो इसको अगर हम क्रॉस करेंगे इससे, तो ये बनता है capital T, capital R, when this is crossed with this, यहाँ पर capital T, capital R, small r. तो ये this is called the tall red. ये वो tall red ये थे. पत इस पर करो इस यथ क्रॉस, ये वुच ये बन ये टॉलरेट पत करो यथ सतन क्रॉस ये बन ये टॉलरेट। तो इसी तरीके से आप यहाँ पर ये कैपिटल टी कैपिटल स्मॉल आर इसको हम क्रॉस करेंगे, फिर दोबारा यहाँ तो बन जाएगा ये, फिर इसको करेंगे इधर बन जाएगा ये। तो यहाँ पर आप देख सकते हैं तो 4 कॉम्बिनेशन प्रोड्यूस 16 कॉम्बिनेशन। तो यहाँ पर टॉल रेड, टॉल वाइट, टॉल रेड। तो इस तरीके से इन टेबुलेटेड फॉर्म यू कैन सी these in F2 generation phenotypic ratio will be tall red 9 plants, tall white 3 plants, dwarf red 3 plants and dwarf white 1 plant. So this is the dihybrid cross ratio 9:3:3:1. So diagrammatically and in tabulated form you will see the 16 combinations. When we cross these ratios तो ये बनता है इस तरीके से 16 combinations and ratio will be 9:3:3:1. So this was all about this Mendels law of independent assortment, and in this way we have completed this question, and it takes 2 lectures. And now in this way the principle of inheritance these 3 principles of inheritance, law of dominance, law of segregation and law of independent assortment, very important questions in the exam point of view. We have completed these questions and nothing remained behind there, nothing is incomplete. We have completely, and this we have tried our best to make you understand these 3 these laws of Mendel. So in this way we have completed in our today's lecture our topic, and this which was continued Mendel's law of independent assortment. And now in our next lecture tomorrow inshallah we will see the other question of this unit 2nd according to the syllabus. Till tomorrow, stay home, stay safe. Thank you very much.